welcome to you who are here in Ream Library and the many of you who are watching us online. I was looking at the number go up and up and up, so there are quite a number of people joining us online. My name is Tom Laney. I'm the director of the Reverend Michael C. McFarland S.J. Center for Religion, Ethics, and Culture, a full title that I rarely use, but this is our first event of the semester, so I'll spell out our full name. The McFarland Center sponsors and supports programs that foster dialogue on issues of meaning, morality, and mutual obligation. And today's lecture is the first of more than a dozen events we have planned for this semester. A really outstanding lineup of award-winning authors, Nobel laureates, Vatican advisors, and renowned researchers and activists. You can find more about our complete schedule online at holycross.edu/McFarland Center or on the MyHC app. I'm pleased to join with my colleagues in environmental studies today, particularly Program Director, Professor Justin McAllister, to welcome Chris Mooney to campus. And I'm grateful to Chris for being generous with his time and adaptable to our campus protocols. He's joined a number of classes and met with environmental studies faculty today and got a good Holy Cross welcome from people. Chris Mooney is a Pulitzer Prize-winning journalist who writes about energy and the environment for the Washington Post and is a lecturer at the Yale School of the Environment. He previously worked for Mother Jones, where he wrote about science and the environment and hosted a weekly podcast. Before that, he spent a decade as a freelance writer, podcaster, and speaker, with his work appearing in Wired, Harper's, Slate, the Los Angeles Times, and the Boston Globe. Chris has published 4 books about science, politics, and climate change. He won the Pulitzer Prize in 2020 for his work on the Washington Post series that explained the dire consequences of extreme temperature experienced around the world. In today's talk, he'll tell us more about his groundbreaking investigation with the Post last year that revealed a significant gap in countries' reporting of greenhouse gas emissions. So please join me in welcoming Chris Mooney.
Thank you, Tom. It really is wonderful to be here. It's great to be on a campus again and to be meeting and talking with folks and being able to actually give a talk in person. And it's really a privilege, and I do feel very welcome here, and it's been great to get to talk to some of you. And thanks, Justin, for being a great guide, and to everyone for having me. Just a quick disclaimer. I work for the Washington Post. What I'm saying here doesn't represent the Washington Post. I'm just speaking for myself, and I'm also not speaking for Yale. So just me. But it's great to be here talking about some reporting that we recently did as part of a series called Invisible. And 5 stories from the series have been published so far. The project consists of one central data investigation, which is the big image, countries' climate pledges built on flood data, but a number of additional stories that kind of draw on some of that data, but also go in more specific and in additional directions, looking at certain countries. And basically what the investigation found was that countries are dramatically underreporting their climate impact by some 10 billion tons of greenhouse gases per year. And to do this, the Post drew on satellite and atmospheric analyses, independent studies of greenhouse gases, and even a data set that we built ourselves. And the goal was to hold the planet accountable for what it's emitting. And so I want to just tell you how we did that. But let me underscore, this was a really big group effort. So here are some of the people that worked on the project. I'm the only one here speaking with you. But a lot of reporters worked on the series. We have a great data team, without whom we would not have been able to do this. Many editors. Most of these people are staff journalists, although some of the photojournalists are freelance. So let me tell you a little bit more about me and before we start and how this story came about. So I've been a reporter at the Washington Post for 7 years, currently at the Yale School of the Environment this academic year. I spent those 7 years covering climate change including visiting some far-flung places around the globe. So here I am at Petermann Glacier, 81 degrees north latitude. Had to get there by helicopter. When you see dramatic changes in a place like this, you really realize that climate change is quite an earth-changing phenomenon. And so I wrote about that trip and many others. But more recently, I've been gravitating towards the possibilities offered by what I would call data journalism, which you can do without going to 81 degrees north latitude, although sometimes it's important to go to places like that. What is data journalism? Here's how the field has been defined by one scholar, Bahari Haravi from University College Dublin, who wrote that data journalism turns on, quote, finding stories in data, and that, quote, in data journalism, data is the source. And Haravi, working with Mirko Lorenz from Data Wrapper, which is a cool tool that I use sometimes for data visualizations, also documented in a 2017 survey that data journalism has a strong foothold in many newsrooms today. So what they found was that a lot of journalists that they surveyed said that their publications had a dedicated data blog or section, or that they were planning to work on some type of data project in the near future. This isn't too surprising because in the media, everybody wants to have exclusive information and exclusive sources and to break news. That's what everyone is competing with everyone else to do. And what is more exclusive than a data set that nobody else has, or nobody knows how to use except for you, or nobody's bothering to use except for you, that contains newsworthy information. And so that's something, that's a kind of journalism we've been attempting to do in the climate reporting team. And we first tried this out in 2019 with a series that you just heard about. It was called 2 degrees Celsius. Many of the same reporters whose names you've just seen. And what we did there was we reported stories from around the world about the places that are seeing the fastest rate of warming today. And the data part was using global temperature data sets to find those places. And many of them were coastal, and so these are some of the photos from the series. Many of the most dramatic changes that we found in the data set involved upending fisheries and ocean ecosystems in a variety of ways. Here's the data itself. It's now actually a little old because we were working with temperature data through 2018. There's 3 more years now. So probably the area is colored red, which means that they've experienced above 2 degrees Celsius or 3.6 degrees Fahrenheit of change since the late 1800s. Probably those are more numerous now, I would think. So that was the first big project that I worked on and had a central role in. And so then came Invisible, and it was sort of the next of these. And here we're not investigating temperature data sets anymore, but what countries are saying about their emissions. And what we found was that we were able to draw on publicly available United Nations documents to build a data set that let us investigate what countries are saying versus what we think is really happening based on other evidence that we can gather from independent scientific sources. And along the way, we also undertook some additional database analyses, depending upon the country, there were different avenues that we were allowed to take and different things that we could look into, and I'll show you some of those as well. Now, let me tell you a little bit about how the series itself came about. Dating back to before the pandemic, we were thinking about looking at the world's emissions and trying to figure out the way into a very, very complicated topic. And so what I did, as I did for the 2 degrees Celsius project, was to start just reading a lot of science. It's something I like to do. Just read the research. And you notice common threads and you follow some of them, and then you find additional threads. And over time, I became aware that there were a lot of studies about how various types of greenhouse gas emissions were underestimated. And it wasn't so much about the number one source of emissions, which is burning fossil fuels and releasing carbon dioxide. The world seemed to have a pretty good handle on that. but it was many of the other gases and the other sectors, other than energy. And let me just give you a couple of examples from the scientific literature. So this is a gas that you may or may not have heard of. SF6 sulfur hexafluoride is a very powerful synthetic greenhouse gas. That means that it doesn't exist unless humans make it. It's not, quote, natural. The EPA calls it the most potent greenhouse gas known to date. It's a relatively obscure source. It comes out of certain components of electric transmission systems. So it's coming from the electric power industry. Atmospheric measurements, as shown in this study, of the gas are way higher than what countries are reporting. Now here's another example. Methane gas comes from many sources. Here's a recent study that says that the emissions from cows, one of the biggest sources, are underestimated. And the reason is that when you estimate methane emissions from cows, what people are often doing is they're using a simple technique called an emissions factor. And basically the way that works is you say, how many cows do you have? You try to get that number as close to the truth as possible. And then how much methane does a cow burp in a year? And then you multiply. That's the real simple approach, but that is how it's often done. And the problem with the approach is that your numbers of cows might be incorrect. You could imagine how that could easily be the case. You could be out of date. There could be some people who aren't reporting all their agricultural activity, or your assumption about the methane release rate could be wrong or oversimplified. What this study says is that it's the second thing. It says that in current industrial agricultural systems, where you're raising large numbers of animals really close to each other, you're raising them to gain weight rapidly, the animals are bigger than some of the emissions factor analyses would assume, and they're also often sicker. And so for both reasons, they're emitting more. And so the calculations are off. So I was reading this kind of stuff, and I was kind of making a list of how many studies like this there were. And at the same time, I became aware of a kind of a quirk in how countries report their greenhouse gas emissions to the United Nations, which is they claim these really large negative numbers on their reports. And the reason is because of forests and land, which they say are storing large amounts of carbon, which happens when trees and plants grow, and of course mainly trees. That's where the main carbon storage is happening. And so the US, for example, subtracts over 800 million tons of carbon dioxide from its reports this way, and so that really dramatically reduces the US total emissions number. And the US is not the biggest. China subtracts over 1 billion tons. And this is done under a system for identifying what is called, quote, managed land. And it's quite obscure and technical, but these are the rules that countries are working under. So let me just explain briefly what it is. Basically, countries are allowed to determine what land within their borders is, quote, managed. And as you can see in the picture, the US concludes that virtually all of it is, although it says that we don't manage significant parts of Alaska. And then once you determine what's managed, you're supposed to report how much carbon goes into the system as the plants grow and how much goes out as, forest fires occur or droughts occur, whatever causes plant life to die and leads to emissions, okay? And the reason it's done this way is that it's very hard to separate in a landscape what is directly caused by humans and what is, quote, natural, so they sort of simplified things. But here's the problem. So countries then claim these large subtractions, but scientific analyses don't credit them with those numbers. So just to give one example, one of the databases that we use in the project as one of our scientific sources, which is the Food and Agriculture Organization of the UN, it does credit the US with subtractions, but it only credits the US with about a little over 200 million. So that's a big discrepancy. And the reason is that because the land is taking up carbon, but it's not clear that humans directly cause that to happen. In fact, one thing that causes it to happen is climate change itself, right? We put more carbon dioxide in the atmosphere, then plants grow faster. Should we be crediting ourselves for that and reducing our emissions for that? And so the scientific data sets generally don't let you do that. Nobody really questions that if you actively plant a tree, you should get credit for the carbon that it pulls out of the air, and if you cut that tree down, you should get credit for that. But what about these things that you didn't directly or intentionally do? Countries are getting credit, but it's not clear that they deserve it. So at some point, it dawned on me to ask, what do the world's reported emissions claimed by the countries actually add up to? Because this has a very direct bearing on their promise to cut their emissions, and they're all making promises. What is the baseline that they think that they're starting from? And it was not exactly clear how this had been analyzed in the past. Certainly the UN Framework for Climate, Framework Convention on Climate Change, under which the countries are doing this reporting, doesn't anywhere give you that answer in a simple, compact form. So I decided to take it on myself to analyze it, and I decided that I would use an advanced technique that I've been perfecting for a number of years. It's called addition. And so for some of the countries, the data were really easy to get and understand. These are the so-called Annex 1 countries, or the industrialized developed nations. There's 43 of them. Here's the United States. It's one of them. That's where that negative 800 million number is sitting on a US filing. And they report every year in exactly the same format in exactly the same units. So it's pretty easy to download this, and it's also up to date on the website of the United Nations in an online tool that they have that shows you countries' emissions, except it's always 2 years behind, right? So the most recent data right now is 2019, but that's probably going to be 2020 pretty soon. And by the way, the data in this talk, it all cuts off around October of last year, which is when we finished the project. So there might be some additional countries, in fact, I'm sure there are, that have filed numbers since then. I don't think it will change the big story very much. But anyway, so there's the Annex 1, and they report in this uniform format. It's easy to work with. Then there's the non-Annex 1, or developing countries. There's an additional 140 plus countries. Totally different situation. They don't report every year. Well, some of them do, but mostly they don't. On the UN's website, the data are often out of date, and it's in wildly different formats. So this is the data on the website for Mexico, and you can see that the last year that you can get on the site is 2013, but if you go to a different part of the United Nations site, you can find the 2015 data. But you have to go and you have to do the work. So it became clear that the job was going to be to get all the Annex 1 data. That would give us 2019 emission levels for all of those countries, and then we'd have to go one by one through all the other countries and see if the data was up to date, or if there was another report that was more recent. And if it was, we're going to have to go into the PDF and pull out the data. So that was where the work came in. So we're digging through these very long PDF files in all these different formats, trying to find a comprehensive reporting table like you see here, where the country's breaking down all its emissions by the different gases. And it's principally carbon dioxide, methane, and nitrous oxide, but there's always some synthetic gases or F gases like SF6 that I told you about. But they're the smallest group, although they're growing fast. So, and if we couldn't find something like this, Mexico is very good, reports in a great level of detail. If we couldn't find something like this, then we had to figure out if there was any way in the document to figure it out. And sometimes we couldn't. And one of the most complicated things is because there's no standard format, the reports actually have different interpretations of how strong the greenhouse gases even are. Right? So this is how complicated this reporting is. Some countries say methane is stronger than other countries. Some countries say nitrous oxide is stronger than other countries. And the reason this is that the main gas is carbon dioxide. And if you want to summarize countries' emissions with one number, then you've got to convert the other gases to the equivalent of carbon dioxide. That's what they do. But they're all different gases. They behave differently. So, basically what happens is you say, okay, over 100 years, methane is 21 times more powerful than carbon dioxide at warming the planet. And that's what scientists originally said in the second assessment report of the IPCC, but then science changed and they realized methane's more powerful than that. And so later reports said it was 25 times more powerful over 100 years, and later report said it was 28 times more powerful. And the latest report has changed it yet again. And with nitrous oxide, it's the opposite story. Scientists have been saying, no, it's not quite as strong as we thought compared to carbon dioxide. So this makes a huge difference if you want to analyze the world's emissions, because Mexico, for instance, is using the 28 times stronger methane, but many other developing countries or non-Annex 1 are using 21 times stronger. You've got to convert it all into common units, so that ends up adding to the complexity. And I'll note that for both of these gases, they're rising really fast in the atmosphere, faster perhaps than carbon dioxide. So we did this. We got all the data, we did the conversions. First I did it myself, then the Washington Post organized a group to do it systematically and check the numbers. And, we found some differences, but basically we found the same thing every time, which is the countries are reporting a little over 41 billion tons of greenhouse gas emissions. So what does that mean? Well, what it means is if you take what every country said in its most recent year of reporting, then the world is taking responsibility for a number of emissions that is what scientists in a study like this one, which is one of the ones we relied on, say were happening in the year 2000. Okay, so it seems like the world is way behind, and emissions have grown a great deal since then. Now, it's not a perfect comparison because, for one thing, the chart here includes emissions from shipping and international aviation, which are really big sources, and countries do not report these international emissions. And it's also using the most recent global warming potential conversions that just came out, which are different yet again, and no country is using. So that adds to the imperfection of the comparison too, but it's not way off. It's actually fairly close. The countries are definitely lower than the scientific data sets. So that was very striking to us. We had to figure out what exactly it meant because the analysis wasn't done when you've added up just the countries' numbers, because we knew that there was an obvious objection that was going to come, and it was a completely fair question, which is, well, aren't the numbers low because the countries are out of date? Aren't they behind? No wonder they're reporting at levels that seem like it's back in time. Some of them haven't reported in a long time, and that's true. The non-Annex 1 countries, some of them, are quite out of date. So it's a very reasonable thing to ask. But when you look at the data closely, it becomes clear that it can only account for a small part of the problem. And I want to show you why that's the case. We do need to get into the data a little bit to do that. So this is the top 40 emitting countries with the year they reported across the bottom, and the amount of emissions on the other axis, and then the size of the bubble is, of course, scaled to the size of the emissions. So China's the biggest, then the US, and there aren't that many that are close to them. And I'm basing my list of the top 40 not on what the countries say, but what, again, the UN FAO says, ranking them in the year 2019. This shows a lot of interesting things, one of which is Taiwan is in the top 40, but you can't put it on this plot because it doesn't report to the United Nations Framework Convention on Climate Change, nor does it appear to be included in China's report. So there's a big missing unreported emission right there from Taiwan, which is part of the discrepancy. But these top 40 countries account for the vast bulk of all the emissions. And as a group, they're not particularly out of date. So the total that these countries report is 37.4 in their most recent year. The total that all countries report is 41.3, again, billion tons of greenhouse gases. And if you then draw a line and say, I'm going to only look at countries that have reported in 2014 or later, then these top emitters in 2014 or later reported 35.3 billion tons. That includes China, of course. If you were to leave China out, it would change dramatically. So that means the percentage of all emissions that were reported in 2014 or later is 85%. So while things are out of date, they're not hugely out of date. The vast majority of reported emissions are from 2014 or later. So that means that we need to adjust the data to take into account this problem, but probably we shouldn't adjust it dramatically because the reports are not super off. So we need to bring the countries up to date, but we shouldn't overdo it. And so ultimately we came up with an adjustment that is about 3 billion tons, right? So, and when I say adjust, I mean we're taking China, India, and any country that hasn't reported in 2019, and we're trying to say, what would they report if they did report in 2019? Because we know that emissions are generally rising, and so we want to take into account in some way that there's economic growth, right? That the world is changing and generally people are going up. And the way that we did this, our team built a model to do it, and basically the model took into account the country's prior pattern of reporting, what it tended to report, but also what an independent data set said that the country's actual emissions were, and how much that data set changed them every year. And then the model predicted what they might report in 2019. That's one way to do it, but we also checked that with a really simple technique, and I think that it's great that they came up with the same answer. So, you can imagine if there's an independent data set, and there's several of them, that give a number for what they think China really reported every year, not just in 2014, the last year China reported, but 2015, 2016, 2017, and so forth. Then you take that data set and you say, okay, in 2014 China said this, in 2014 China emitted this, in 2019 it was 10% higher, okay? Then you just take what China actually reported and adjust it upward by 10%, and you do that for every country. And that also gives about 3 billion tons. So that's how much we changed the data. So they reported 41.3, we raised it to 44.2. And I just want to emphasize, there's no such thing as the truth here, because the countries, we're predicting what they would report in 2019 if they had reported, but they hadn't reported. So you can't say, it's not about what happened, because it didn't happen. What you're trying to do is you're trying to be reasonable. You're trying to take into account the passage of time and the fact that there's economic growth going on and things are generally going up, although in some countries, if there's a war, if there is an economic crash or collapse, then emissions might actually go down, and there are a couple cases like that, but mostly they're going up. So that's what we did, and this is what we thought was reasonable. And then once we'd done this, whatever's left, the remaining emissions that are missing, right, and it's still quite considerable because the independent data sets were at 52.7, 53.5, and 57.4. These are the Food and Agriculture Organization of the UN, the Global Carbon Project, and a study that I actually just showed you by Minks et al., which uses a data set called EDGAR. So they're all way higher, and EDGAR is the highest of all. So you still find this gap. And once you've got this gap and you've adjusted the data, then you think you still have a problem and you should write about it, which is what we did. And I want to emphasize that if there's missing emissions, it doesn't mean that they're coming only from the developing countries or the developed countries. They're coming from both, right? The missing emissions are in both groups of countries. And in fact, the fact that we've done this adjustment, whatever's left means that we've taken care of that so that we have to look at both groups of countries. So we're not blaming one group over the other. So where does the gap come from? Then we broke it down by gas, and we found that the gap is mainly carbon dioxide, but it's not fossil fuel carbon dioxide like we thought, although Taiwan is fossil fuel carbon dioxide, but Taiwan is a special case. We think that it's mainly land. It's mainly that managed land problem that I talked about. Second, we think countries are missing a large amount of methane gas, and they're missing a lot of these synthetic fluorinated gases. They're not missing much nitrous oxide, but we'll get to that in more detail in a minute. For the land use change, this is a giant problem. As a whole, the countries are claiming that their land is a negative number, that it's subtracting from the total reported emissions of the world by a couple billion tons. But the independent data sets are saying it's a positive number, as large as 6 billion tons. So again, that's in the biggest data set. So it's a really big discrepancy. So the core of the problem is land and methane. So let's go into those in a little bit more detail. And starting with land, and when I say land, I mean forests and everything else that's growing on the land. It is a hard thing to study. It's a hard thing to understand. It's not like fossil fuels where you basically are just dealing with combustion. Something is burning, and you have to understand the physics of that, and you'll understand the emission. You need to know how much coal is burned to know how much CO2 comes out of that. Biology is a lot more complicated than that. Carbon goes into the plants as they grow. It goes out of them as they die, burn, go through a drought. It moves in two directions. So it's not just an emission, it's also subtraction, and there's high levels of scientific uncertainty. So it's not a surprise that we find this gap here, but it's still very concerning, the magnitude of the gap. And so let's look at one place where the gap occurs. This is an image of a neatly ordered palm oil plantation in Malaysia. Malaysia was a country that to us kind of captured this problem with how countries report what's going on in the land sector. And Malaysia has seen enormous land use transformation over the last several decades in the interest of the palm oil industry. And basically what's happening is these very, very carbon-dense natural landscapes, they're called peat swamp forests, they're being cleared, right? And then they're not just cleared of trees. You essentially have forests coming out of a swampy or very moist landscape. So first you clear the trees, but then you also drain the water out in order to make room for what you're seeing, which is the palm oil plantation. And the verdict of scientists is that it's super carbon intensive to do this because first you're deforesting, but there's also a huge amount of carbon in the swampy, peaty soil. And once you drain the water from that, then it starts emitting greenhouse gases because it starts breaking down. The water was preventing the oxidation, as they call it, of all of that carbon in the soil. And that carbon in the soil is from the trees that have died and have decomposed, but not completely. They're still there. And then they can decompose once you drain the water. So let's look closely at what Malaysia is reporting. And something jumps out at you. So I plotted the data for Malaysia and 9 other countries in Southeast Asia based on how much carbon they say their forests are storing in their most recent report. And then I compare that to the total forest area that the country is saying that it has. Right, so the size of the forest in square kilometers is over here along the bottom axis, and then the y-axis is the amount of carbon that they're saying that they're storing, actually carbon dioxide. And I've colored the dots differently based on the year of reporting. So Malaysia, Vietnam, Thailand, and Indonesia are green because they all reported in 2016, so they're quite up to date. And the rest are older, and the Philippines and Myanmar are quite old. And Cambodia is not here because the country actually is not claiming any carbon storage. It's claiming carbon losses, so I didn't put them on the chart. Now, why did I look at forest area? The forest area is not the only thing that controls how much carbon the trees are pulling in, but it's a huge factor. I mean, that makes perfect sense. The more forest, the more acres of trees, all of them are growing, the more carbon is being pulled into the body, or the trunks, or the leaves, the branches, etc., roots of the trees. So that's going to be one key factor that's going to influence how much they're pulling carbon out of the air and putting it into plants. So I just fitted a linear slope, linear regression to these data, and not surprisingly, there's a good relationship between the area of the forest and the carbon that the country is saying is being stored, and that's what the relationship looks like. And when you do it, Malaysia jumps out because the country's forest is not that large, but it's claiming a very large amount of stored carbon. And the only country in the region that claims more is Indonesia, but Indonesia has a forest 5 times the size of Malaysia. And even so, Indonesia's number is only a little larger. And the other outlier, Papua New Guinea, is an outlier for the opposite reason, which is that it's quite large in its forest area, but for whatever reason, it's not claiming a lot of carbon being stored. So the effect of what Malaysia is saying is happening is really dramatic. So we calculated the country reduces its emissions 73% by it. So Malaysia says they're emitting 81 million tons in 2016, but the FAO puts them at 422. So the FAO would rank Malaysia easily in the world's top 40 emitters, and kind of the size of countries like Turkey, Pakistan, Argentina. But Malaysia is saying it's more like Belgium or Greece, or a relatively small country in Europe. So what is happening here? We looked into it more closely, and we found that the experts didn't know what was happening either. So these various reports that the countries do get peer-reviewed. And in this case, there was a technical review from the UN experts when Malaysia made a similar claim through another UN program. It's called RED+, and I could tell you what that is in the Q&A, but it's a complicated thing, but it's another UN program. And the reviewer said that this is an unusually large figure and transparent information is needed to justify it. And they said that they used three methods to try to reproduce the large figure, and they shared the results with the party, and they could not reproduce the figure. And so they wrote that, quote, all three estimations undertaken by the team resulted in much smaller amounts of removals, that means removals of carbon from the atmosphere, than Malaysia had reported in its submission. So we thought that we were onto something here, and it's not the only thing with the country's pattern of reporting. Another thing is that Malaysia says that land is not being converted to farmland or cropland within its borders, even though you can see that happening. So this is a 2015 satellite image of a palm oil plantation in Sarawak, Malaysia, on the 28th of May 2015. It's a well-established plantation, but the images from Planet Labs PBC show us that by 2016 the plantation has grown. And we knew already that this had happened because in this particular case, this plantation expansion was studied by scientists, and there's a scientific study about it saying where it happened. And so that we also know that the expansion was on peatland, and the peatland was drained. And the scientists found that per hectare of land, 138 tons of carbon went into the atmosphere during the conversion. So again, I looked at other countries in the region, and the ones reporting recently: Cambodia, Indonesia, Laos, Papua New Guinea, Thailand, Vietnam. They all report emissions from the clearance of land and conversion of land to cropland. It makes sense, right? You're taking down a forest in many cases. So of course there's going to be some emissions. So again, Malaysia was doing something different from the other countries. And then when the land is cleared for cropland, if it used to be a peat forest and it's drained, then scientists have found that the peat, which is now dried out and exposed to the atmosphere, it emits first a burst of emissions, but then it keeps on emitting for decades. And so then we analyzed what Malaysia was claiming was being emitted from the drained peat that had already been drained. And those numbers, again, were low compared to what other scientists were saying. So this was a case where it looked like there were just a lot of ways that in the land sector, a country's numbers were coming in really low compared to the sources that we had. But it's not that we think that this is the only country in which this is occurring, no. We think these kinds of problems are happening a lot. In many cases, we think it's countries that are claiming carbon is being pulled out of the air, put in their forests, and it's really happening. It's just a question of whether they deserve credit for it. In this case, we think it's probably being overclaimed, and not all of it is happening. So that was one of the problems. The biggest problem the story found was this issue with land and forests. But the second really big thing we found was about methane gas, right? The second most important greenhouse gas. And compared with the scientific data sets, countries appeared to be reporting a lot less methane. And we're talking about tens of millions of tons of emissions of the gas per year. The second largest discrepancy. And we think it's happening around the world. It's happening with rich and poor countries alike. It's just a gas that is not being well tracked. And, a lot of it has to do with oil and gas, but a lot of it also doesn't. There's methane coming from agriculture. There's methane coming from the waste sector, from landfills, from other sources. It seems like it's sort of a systemic problem with this particular gas. But in this case, satellites are starting to become capable of detecting methane leaks, the large ones, in real time. So they can detect a blowout in the oil and gas sector if it's large enough. They can't detect, they can see a steady sort of emission in an agricultural area, but that's not a big dramatic event. It's more likely to be steady. So we use this data in one of our first stories in the series, which was about methane from the oil and gas sector in Russia. And there's considerable evidence that Russia's estimates for these leaks and for overall methane from oil and gas is too low. And again, I want to be clear, we don't think Russia is the only country where this problem exists. It's been found in many scientific studies that the numbers are too low in the US. It seems clear that the numbers are too low in the Middle East. It seems to be something with the oil and gas industry and methane leaks in general, but we focus on Russia because it's one of the largest of all the oil and gas methane emitters, and because of all the new data and analyses that satellites were starting to provide. And so here's some data. And the gist is satellites give significantly higher results for methane emissions from oil and gas than Russia's reporting. So these are the 2017 figures for 17 satellite-based inversion models. And what that is you take satellite readings of methane in the atmosphere, including the large leak events, but also just the general methane. And then scientists run a model, an atmospheric model, to try to figure out where it came from and attribute it to different sources. And the models do it differently, and so you can see they get different results. But I've colored red what Russia reported for the same year. And the vast majority of the models are giving us something larger, and the median result is significantly larger. And we looked at a lot of independent data sets, some of which don't even use satellite techniques. They use different approaches, and they all give bigger figures for Russia's methane emissions from the oil and gas industry. So what we decided was, the body of evidence suggests that the Russian reports are too low. And also, we turned to experts at Harvard and the Environmental Defense Fund. They conduct these analyses that I just described, called inversions. And they did an additional one just for us. And they ran multiple models to try to figure out what Russia's emissions were. And they got a result that was about double the country's report. And I actually also wanted to show you, our graphic team is really great at the Post, and when I'm presenting here, I'm standing on the work of a lot of other people. So I wanted to show you one moving graphic we made, which is about how Russia reports its emissions from oil and gas, methane from oil and gas, and how it's changed dramatically. So each year, if you're one of these Annex 1 countries, you report the emissions for every year, and then you report them again. So in 2006, you'll have reported for 1990, 1991, and so forth, all the way up to 2004, and then you stop. In 2007, you'll add one more year, you'll report for 2005, et cetera. So that's how it works. So here's the video. So these are all the different numbers in the different reports, right? So they started out around 2006, saying it's about 10 million tons per year. But in 2015, it goes all the way up as much as 30, for some of the same years, right? But in most recent years, 2019, 2020, 2021, it's been really low. But it's been all over the place. So the numbers are being revised constantly. And it's not that this is the only country in which this is occurring. These kind of revisions are happening a lot. So then if you take 2016, they've reported on what happened 3 times so far, and they've reported 24.9 million, 6.3 million, and then 4.3 million, all for the same year. And it's not that what happened in that year changed, right? That year's already happened. That's the past. What's changed is the way of estimating, right? So what happened was a recalculation of the estimates from the oil production sector. So it shrank by 90%. And again, this is this issue with something called an emissions factor, where you say, okay, how much oil production do we have? And what do we think the leaks are? And we just have some number, some sort of percent for how much leaks from various parts of the oil production system, and then you multiply it by the oil production, and that's what you get. And so if you change that number you're multiplying by, then the result changes dramatically. And then the most recent report is the lowest. And when the reports are really high, scientists who are doing these independent satellite-based analyses thought they were too high. But now that they're down where they are now, scientists think they're too low. So they think the truth is somewhere in between. Another country where we looked at the emissions and did a whole story was Mexico. And here we wanted to look at the agricultural sector. And Mexico, does a really detailed job of reporting, as I mentioned. And when we showed them some of the independent research, again, based on satellite techniques, and they said, yeah, we understand, they're using a different method than we are, and so we're not surprised that they're getting higher results, essentially. They didn't really dispute it. This story was mainly done by Josh Partlow, who's a great foreign correspondent of ours. And Josh visited the Yaqui Valley of Mexico. This is a major breadbasket in the country that was central to the so-called Green Revolution, when agricultural productivity was greatly increased. And a lot of the early agricultural experiments were here. But it's been really well documented that too much fertilizer is used. And this is nitrogen fertilizer. And when it's overused, then nitrous oxide emissions occur. And the research suggests that if you put on too much fertilizer, up to a point, if you're using the right amount, plants use it, and the emissions are relatively low. But as soon as you start to use too much, the plants don't need it anymore, and then the emissions rise, and they don't rise in a linear way, they rise in an exponential way. But that, again, contradicts the way that the emissions factors work, which is that you just multiply. If you use 10 pounds of fertilizer, then you say that 1% of that went in the air. If you use 20 pounds, you also say 1% of that went in the air. But if the plant only needed 15 pounds, then that remaining 5% is not going to be 1% anymore going into the air. It's going to be more than that. That's what the science shows, and this is why these numbers continually seem to be going awry. We're not trying to criticize Mexico. Mexico is just a good place to tell the story, but we think this kind of underestimating is happening all around the world, and so do many scientists, and they've written many papers about it. With nitrous oxide, which is primarily a gas that comes from agriculture, and again, a lot of it comes from fertilizer, the striking thing was that when we did the whole global analysis, we didn't find that the numbers were too low. We actually found that what countries were reporting was consistent with what the independent scientific data set said, but yet in Mexico, we think the numbers are too low, so what's going on? It seems like some countries must be reporting too much to balance it out. And so it's a different kind of problem where you have the global number might be right, but the individual responsibility for the global number is off. So you don't want that situation either. It's not as bad as a situation where, total reports are too low, but it's still not a good situation to have. We want accuracy, and we want to know who's responsible for emissions. So what does it all mean? It's on the docket for the Paris Climate Agreement to get this kind of reporting to be better. There's something called the Enhanced Transparency Initiative. By the end of 2024, there's going to be a new, better regime for reporting. But that's going to take a lot of getting used to by the countries. And it's not clear whether, if they're using some of these same methods that I've said seem to undercount things, whether the problems will go away just because you have new. What that regime is going to do is going to have more frequent reporting, for one. And it'll also make reporting more uniform, so everybody's using similar standards. So that will help the problem of time. It'll help the problem of these really incompatible numbers, but it won't address something wrong with the methodology, which is what we think is a key part of the problem. So the next question is, and the one that everybody wants the answer to, is what does this mean for the promises? That's what we care about. Every country is promising to cut its emissions by different amounts. Oftentimes it's a percent by a certain year, but sometimes it's, as a percent of the economy, things like that. Unfortunately, we can't give you a precise answer because that's a whole separate analysis. But we don't think it's good news. It seems to me that unless you think that the emissions that countries don't report are just as likely to be cut as the ones that they do report, you should be concerned that they're underreporting and that their promises might not be borne out. And I definitely think that if they're missing the emissions in their reporting, that they're probably likely to not be able to cut them as well because for some reason they're not tracking them. And I'll just say something else. The problem about land, which is the biggest part of the problem, is going to loom larger and larger in the future. And that's especially the case as countries start to try to implement the promises they've made and start trying to show progress, because it's going to be very tempting for very large countries like the US and Russia to claim that because of their forests, they've reached their goals. even claim that they're net zero, right? They're not having any net effect on the atmosphere, even though they're still emitting greenhouse gases, because they'll say the forests are soaking up so many emissions. And I think that kind of approach, as it starts to occur, and it will, if countries actually reduce their emissions but continue to claim these large negatives, I think it's going to become quite controversial. So I think we need a great deal more transparency, yes, more frequent reporting, and that will certainly help us get to a world where emissions reductions are happening and we can document and believe it, but I think we have to also look at the methods that are being used. And so it's not just about reporting on time, and it's not just everybody using the same units, although that would be good, but it's how are we actually measuring. And ultimately, I think we need to rely a great deal more on independent measurements and satellite-based techniques for measuring changes in forests, emissions of methane, emissions of nitrous oxide. They're in use now. They're going to get better. There are going to be many more satellites. And ultimately, I think that that's going to be one of the things that we need so that we can really understand what is happening out there. The issue is, will we know fast enough to curtail some of the worst impacts of climate change? And given the timing that we have, that is, I think, the most pressing question. So I will end there, and I'd be happy to take some questions. Yes.
Chris, real honor to have you on campus.
Thank you.
There has to be concern for feeding the planet and maintaining the carbon budget in ways that really promote kind of high quality of life throughout the planet. But at the same time, that nitrogen addition is always going to loom as a potential greenhouse gas. And so your description of how we don't appreciate N2O, I think, is really, really valuable to the scientific literature.
Thanks.
So with that said, how do we do a better job, though, of regulating fertilizer emission in a way that feeds the planet, potentially fertilizes the planet in selective areas to promote forest growth or even growth in, say, the southern Pacific, but at the same time doesn't set the stage for lots of N2O via anaerobic process?
Yeah, I mean, it's very difficult because if you read Josh's story out of Mexico, and I just wrote the science reporting part, so it was really not my work. It's really detailed and sensitive depiction of the farming community in the Yaqui Valley, where it has been documented the exponential growth of emissions once you over-fertilize definitely happens in this place, and it happens because of the farming techniques they use, but it's happening in a lot of places. And the farmers, for them, it's insurance, right? It's like, why not use a little more fertilizer? Because just maybe, I mean, what does it hurt me? It just maybe I'll have a better crop. Right? And so the environmental cost is not the front of their minds. They're really trying to just ensure the growth of the crop, and they don't see that as a big loss. And how you change that mindset is a sort of a sociological, I think, thing. And because this over-fertilization problem is happening in many countries, I think you really need to, it's sort of educational, but it's partly sociological, and it's sort of the mindset of farmers who are really risk averse, and they figured this is just one way, of ensuring. I think one of the quotes from one of the agricultural scientists is that a farmer said to him, I may not get this right, I added such an amount of nitrogen as fertilizer, and they added 20 more pounds as tranquilizer, right? So just to lower my stress level. So, I mean, the cost of the environment is not taken into account. So until that cost is working its way in somehow, it's not clear what you can do.
Thank you for your report.
Yeah.
Can I ask you to reflect on the leaks, I guess the carbon dioxide and methane leaks from the energy sector? I've sort of read sometimes that maybe there's a little hope for regulation there because some of those might be easy to identify the leak
Yes.
sources. Now there's point sources, which are much easier to regulate.
Yes.
The nitrogen and some of these non-point.
Right. It has been pointed out convincingly that, sort of people use, these are cliches, low-hanging fruit, that this is low-hanging fruit, right? Because if you don't leak it to the atmosphere, then it goes in the pipe, and then you sell it, right? So that should make you happy, right? You're doing gas production, but that doesn't apply to the oil sector, right? They want the oil, they don't want the methane that comes up at the same time. So the logic only goes so far. But yes, for that reason, there has been some optimism that some of these practices can be improved. But yeah, right now the emissions factors, it's just too simplistic an approach. And what the scientists told us is that when scientists do studies to try to figure out the emissions factor for a piece of equipment that might fail, how much would leak, they usually are working on good equipment, right? They're not studying old equipment. And so they're not really getting all the problems in the system into the analyses. So I think that's what's going on. Yeah. Some other questions? Yes?
So I was really struck by the diagram you showed of the United States, in which they consider the entire lower 48 as managed land without any consideration of differences in biomes or suburban versus urban versus rural areas. Is there any indication that might change going forward in the future?
Not that I'm aware of. I mean, the thing about managed land, this was a scientific compromise, right? Because the scientists could not tell. You want, the background here, right, is that you want countries to report human-caused emissions. You don't want them to report natural emissions or natural subtractions. Like subtraction would be when the trees grow. But it's very hard to distinguish the human input in the forest from the natural input in the forest, right? They just couldn't do it. So they just said count everything, right? That's what happened. And not just count everything, but you define managed your way. So what does managed mean? I mean, so some things that could qualify land as managed might mean that we're ready to fight a fire if one occurs, right? But that could be a wilderness, except, yeah, we can deploy to this area. So is everything happening there really under the control of the United States? Not really. But many countries are claiming large parts of the country. Yeah.
So do you think we're kind of just like doomed, future generations to like the amount of CO2 like being cut down or like are not really true, like stuff like that? Do you think countries are actually trying to make an effort to change their ways of CO2 or no?
No, I don't want to say that countries' efforts aren't real, but I don't think the data system that tracks what's really happening is working well enough to hold them accountable. Doesn't mean that they don't want to reduce emissions. I think that they really do. But emissions are not, most countries do. Emissions are not going down fast enough. I don't think we're doomed because I think we're going in between two extremes, really. One extreme would be the dramatic cuts in emissions that are what you need in order to avoid certain thresholds that are very close. So 1.5 degrees Celsius of warming, 2 degrees Celsius of warming, those are coming. And to me, why I say extreme is that you would have to cut emissions so much so fast, and these thresholds are coming relatively soon. I don't think the world is turning the ship that fast. But the world is turning the ship, and so I don't think you're going to go to the other extreme, which is the really high levels of warming, because I think we are going to lower emissions. So I just think that we do not seem to be mustering the potential to change rapidly. But we are mustering the potential to change. But science is unforgiving, and physics is unforgiving, right? And you have to, the science says you have to change rapidly. Human societies are like, we don't do that, basically, even though the intention is there. That's my read on it. But not tracking what's going on is definitely an impediment. It's not the only impediment, because the ability to change rapidly is just, it's something that it's not clear that it's possible. One of the most influential reports from the UN Intergovernmental Panel on Climate Change about 1.5 degrees Celsius of warming and how close we are and what the impacts of that would be, basically says that in order to avoid it, you need a technological transition of the sort that we're not sure that has happened, right? You need to change the whole energy system. You need to do it in like a decade. And that's just a really steep thing. So, but that's not the same as doomed. Doomed, I mean, basically, I just don't think that's the right way to think about it. I think that basically, as you cross the thresholds, you increase the risk of bad outcomes, and that means damage to the planet. And that means that if you think about it from the perspective of, my daughter, that maybe coral reefs are not going to be something that, when she's old enough to scuba dive, are going to be easily seen. I don't know. You're going to lose things from the Earth. It's not that the Earth is not going to be here. It's not that we're not going to be here, but there's going to be real losses. So, I mean, to me, that's not doom, but it's very, very consequential. So, I don't know. Does that help? That's kind of.
Yeah, no, I understand what you're saying.
Yeah.
We're gonna lose certain things as we keep going.
Yeah, you just keep going further, and you're putting at risk new, really big parts of the planet that are sensitive. The reefs, we know, are really sensitive. I always use them as an example because it seems like they're one of the things that comes first. But if you go further, some other system might get vulnerable. So.
Thank you very much.
Thank you.